Lesson 1-2, Solving Multi-Step Equations, Day 2. Solving linear equations in one variable is our skill that we're working on. We've already done the one step, we've done two-step. Now we're really working on this multi-step linear equation. We've been finding we've got one solution, and then you can see as well, we're talking today about terms and like terms. We've already kind of gone over some of these other ones with distributive property and linear equations. We're really working on completing all this vocab along with constants and the properties. So that way, again, when all the vocab is done and our skills, that points us up to our standard that we can solve linear equations in one variable, however they look. A term is a number, say 6. A variable could be m, or a product of a number and a variable, say 3x. That's just a term. It's anything in the equation, like terms that have the identical variable parts. So they have 3x and 2x. They have the same variable with the same power on it. Now, again, we're just talking about multiple step equations today. Hint, use inverse operations to isolate the variable. Our goal is just to get it back to a two-step equation. A two-step equation where we know step 1, we're going to add something, and step 2, we either multiply or we divide. So in this example, we're going to focus here. We want to isolate the 1.5x. So we're going to get rid of this first, adding a negative 15 to both sides. Why? Because the 15s cancel. You are left with that 1.5, 1.5x, equals positive 9, mental math, calculator approved. Step 2, you multiply or divide. Since the 1.5, the 1.5 is touching or timesing the x, you will divide, which gives you x equals 6. Any equation, our goal is to get it back to a two-step equation. Oh no, there's so much going on over here. That's okay. Combine your like terms. Since the negative 2 and negative 2m and the 4m are like terms, add them together. That gives you a positive 2m. I'm going to cross them off. And you can see the only thing left up there is a positive 5 on the left side, not a like term, so I'll bring it down along with the negative 3. Now we have ourselves a nice two-step equation that we can do our 2 steps with. Step 1, I'm going to get rid of adding that positive 5 by adding a negative 5 to both sides. Why? They cancel out. So you're left with 2m equals, and here's why the mental math works well, because when you take a negative 3 plus a negative 5, 2 negatives added together, losing money twice gives you a negative 8. And then from there, we're just going to solve for that variable. Divide by 2. You're left with m equals a negative 4, because do these guys have the same sign? No, means we need a negative number. Always just trying to get it back to a two-step equation. If it looks something like this, don't panic. First off, if there's ever any subtraction, don't subtract, add the opposite. Next, make it a two-step equation. Here, right away, we're going to end up using our distributive property. So take that negative 4, draw the line. Yes, draw it, so that way you remember that you need to multiply those to give yourself a negative 12g. Plus, take the negative 4 times a negative 5. Very important that you get a positive 20 there. And then from there, there's nothing else in the parentheses, so I'm going to rewrite the entire equation so we can see it. You could technically just write that blue above the parentheses and save yourself a line. I explained that better in class, but moving on for speed's sake here in the notes. Again, combine like terms. I see a negative 12g here. Any other terms, any other things with a g in it, circle them up, add them together. When you add those together, we're going to end up getting a negative 2g. I'm going to cross those guys off. And then that leaves us up there with the plus 20 equals 19. We now have it back to that two-step equation that we were looking for. From here, isolate the -2, get rid of the 20 to start with. We're going to do that by adding a -20 to both sides. In doing so, that cancels out, so we're left with just -2g equals -1. To solve, we're going to divide by -2. Step 2, you always divide by the same thing. You're welcome to change it into a decimal if you'd like, or just leave it as a fraction where g equals. Now, if you divide it on out, you're going to find out that it equals 0.5 or positive half, positive 5/10. Or you could just leave it as a fraction where, again, when you look at these, since they're both negative, two negatives, it's going to leave you as a positive. I will accept the fraction. I will accept the decimal. All this to solve equations in one variable. Notice we're talking about terms and like terms, constants that have no variable with them, using the distributive property, continuing to use the properties of equalities where we're adding the same thing to both sides or multiplying and dividing both sides to work on this multi-step linear equations and solving them where we have one solution. Again, no matter how they look, we're trying to get them into a two-step equation. If there's any subtraction, switch it to adding the opposite. The opposite of a +1 is a -1. From there, we're then going to distribute. Take that 1.5, draw the line. So remember to take the 1.5 times the 2d to give you 3d, plus the 1.5 times a -1 to give you a -1.5. Nothing else inside the parentheses, so I'm going to copy everything else outside of the parentheses. And now combine like terms. Anything else with a 3d? Nope. So I'm going to write down 3d, cross it off. The other things that remain are 5 plus a -1.5. So that's going to give me positive 3.5. And I'm going to bring down that 0.5. Again, here we have our two-step equation, trying to isolate the 3d. I'm going to get rid of adding that positive 3.5. To do so, I'm going to subtract, yes, but I'm going to add a -3.5 to both sides. Why? Because it cancels out. We're left with 3d equals a -3. To solve that, we're going to again just take both sides, divide it by 3. So we get d equals 3 divided by 3 is 1, but since one of them is negative and the other is not, they are not the same sign. Final answer, d equals a -1. You score 7, 10, 8, and 9 on 4 quizzes. What do you need on the 5th score so your mean or the average score is 8? Write an equation and solve. Now you could guess and check, and that can work, but since it says write an equation, let's do that. That will also, for most of us, help us to solve it faster and get to the answer. Now, since we're talking about the average, we're going to take and add up all of these scores, the 7 plus the 10 plus the 8 plus the 9, and then it says here on this 5th quiz, which we don't know what that is, so I'm going to make that X. And then it wants our average score to be 8. There's 2 different ways you can set this up. I myself like to write it as an equation, as a fraction. So I'm going to divide it, because to find the mean, to find the average, you have to add them all up and divide by how many there are. 5. If you don't like it set up that way, you add them all up, and then you divide them by 5. Either way, you add up all your scores, divide by how many there are to find the mean or the average. I'm going to do it this way, because then from here, we can just quickly keep that 5 on the bottom, and then you'll notice on the top we have a lot of things we can simplify. So adding the 7 and the 10 and the 9 and the 8 gives you 34 plus the x, and that still all equals this 8 over here. So from there, what I'm going to do is I'm going to kind of treat this like the top here has a parenthesis around it. I'm going to focus on this dividing by 5 first because I want to get this 34 plus x all by itself. I'm trying to isolate the x, so I got to get rid of this dividing by 5 first. The inverse of dividing by 5 is to multiply by 5. So here we go. Multiply this side by 5 because that cancels, and that side by 5. Forgive me, I ran out of room, so I'm going to move over here. My device doesn't quite allow me to extend my screen like I can in my classroom, but that leaves me with 40 on this side. And then on the other side, I've got my 34 plus x. To get rid of that again, I'm just going to get rid of this, adding 34. I'm going to add a negative 34 to both sides, which leaves me as x equals 6. So I can score 6 on that. Now, you might be saying those didn't follow the same 2 steps as normal. When we talk about a multi-step equation, we're really just trying to solve it in whatever steps it requires, whether there's multiple things to distribute and combine. If you get it down to a usual or normal 2-step equation, great. These ones happen often. I shouldn't say often. They happen every once in a while where they got a good question like this. So this sequence of solving may seem a little different. So if you'd like another example, please let me know. Otherwise, today we're still solving one variable linear equations. Today, though, you saw many times where we had multiple step equations, whether we were using the distributive property, but we definitely had to talk about like terms, constants, and terms as we're adding them all up and getting this one solution for us to solve equations in one variable. Today, solving multi-step equations using inverse operations with combining like terms and the distributive property.